Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I am your host, Robby Russell. On this episode, we are joined by Aaron Blohowiak, who is a senior software engineer at Netflix. Aaron Blohowiak, welcome to Maintainable.
Well, thank you so much, Robby. I'm really excited to be here.
You know, I was actually looking through my email and spotted some old conversations. You were actually a customer of mine as a hosting customer back in the early era of the Ruby on Rails community. So I found a couple of support conversations that had happened way back then. So hope that experience wasn't too bad for you. But so I know we've known each other for quite a long time in the community, and there's been a number of mailing lists and such that we participated on early in the Ruby on Rails community. So
in the world we live in today, it's surprising to even think about like how difficult it was to find hosting that worked with Rails. Today, you can host whatever you want. You have your container, you can have your Terraform, whatever you want up to the cloud. But this was a teenager's lifetime ago. It would have been where it was tricky, and there was TypePad that kind of sort of worked. And then Planet Argon came along, and they were like, we understand Rails, and you can go ahead and deploy your stuff. It all just kind of worked. It was pretty amazing.
The challenges of deploying on, I think, cheap hosting solutions, because I think a lot of us didn't have a lot of money to spend, $20 to $50 a month on a hosting solution for our fun little side hobby project felt like a lot of money to spend on something. So I'm glad that I got to go through that period, and now it's like, we're dealing with much more complicated deployment strategies that I feel like you need a PhD to even understand how to navigate. Having said that, so since then, given your experience in the industry, what do you believe are a few common characteristics of a healthy and well-maintained code base?
Well, I am not a huge believer in cleanliness of the code on the page, which is kind of controversial in communities that care about maintainability and operability and debuggability. But to me, as long as the code that I'm looking at fits within a few screenfuls, I'm not super particular about that. To me, I'm much more interested in what I would refer to as like a conceptual integrity to the code base. And, over time, all code bases accrue complexity as they increase their utility and functionality. And so the question is, as they do that, is the core domain model that they have being compromised in the process? And so it really comes down to not only like, are you refactoring not to make it so that your functions are short, but are you refactoring to make sure that like your basic entities still make sense? So like if you have a user model and then it turns out that your subscriptions can be shared by multiple users, are you going to factor out the subscription parts of the user? Or are you going to do some kind of kludge where you have a couple extra Booleans in a field on your user model to say, hey, this one's actually associated to that other, right? And so that kind of like, conceptual purity is really what I find helps things go for the long haul. And it also tends to have the highest inertia to fix. So I think that would be the thing that I really look for when I'm entering a 10-year-old code base.
You gave it that example of like a user object. I think that tends to be a pretty common one in most applications to balloon in size way beyond to the point where you're always worried that's going to burst at some point, but they still manage to keep accruing more and more and more. And you mentioned that subscription model kind of aspect there, or a subscription scenario. Do you have some examples of how you've been able to cleanly move some of that stuff out of, let's say, a large user class object model?
Sure. I think that I like to do things in steps. And even if some of the intermediate work ends up getting thrown away, it's worth taking the long way around and avoiding like a big bang switch. So for this particular kind of refactoring, what I'd like to do is to create a model that represents like the legacy user, if you will, which is going to look like a view, to use a database terminology, onto the combined user and subscription model. And then you can start to do the decoupling behind the scenes while most of the consumers of these objects still have that combined legacy view. Then you can track down all of the users, or what you think are all of the users, migrate them over to the newer, cleaner domain, and then eventually insert some really good logging in that legacy user object. If you don't see those logs for a while, YOLO. Hit the delete key.
That's helpful to kind of kind of think about that. Like there is a lot of, I think, sometimes challenges for developers when they're working on things like, I would love to change this, but I don't have the time right now to do it all, to get it to
Oh
this other
yeah.
part. And so to think about this kind of like, there's these intermittent, as you said, intermittent steps, the long way around. How do you phase yourself into a certain approach? And sometimes it's like, if you don't, I wonder if like a lot of people just don't have yet that experience of being like, okay, is it that I need to come up with the ideal scenario over here, and then we just need to kind of go back and forth between two? Or is it like, what does that intermediate step look like as a first, it's like, what do I extract first? And is it, I think that can be kind of like a conceptually hard for people to wrap their minds around a little bit. How did you learn about that? Is it like literature that you found that was helpful with that, or just working with different teams, or just experimentation, a bit of everything?
Yeah, I think there's a lot to unpack there. I think that fear that people have is well grounded. I spent the better part of a decade consulting or working at various startups, and there are a couple that I think largely failed because they were refactoring before they'd found product market fit. And so there's always this question around like how much maintenance is appropriate. So like I'm a hobbyist woodworker, and you could spend all your time working on the shop itself and not actually producing stuff for the house, for instance. So I like to wait a little bit before I actually take on a refactoring, live with the stink, if you will, so you can really understand the most painful parts, and then wait for a really great opportunity to do a refactoring. And so I like to hook those refactorings into some sort of new ask from the business. And then you can call it, Camille talked about sandbagging your estimates. And I would say having a healthy appreciation of ongoing maintenance as part of expansion, but it's the same thing. And if you haven't heard that episode, it's great. She's awesome. A hero of mine. And as far as trying to understand when I learned this pattern, I believe that's called the strangler pattern, which is not about people, it's about a plant. And so there's a parasitic vine, I believe, that wraps itself around a certain kind of tree, and it uses the tree as like this framework for its own growth. And then it ultimately ends up killing the tree, but then taking its place because it's used it to like create this new structure. And I believe that's Martin Fowler is where I picked that one up, but I'm not sure. I spent way too much time reading C2 Wiki back in the day, and that's definitely the school where I learned a lot of my practical knowledge.
The strangler pattern comes up in a lot of, by a number of different people on the podcast in particular have referenced it, and I do think it actually does come from Martin Fowler. I think it's in refactoring, but I might be wrong too. I'm sure you're right. It's definitely on the C2 Wiki. And if you're listening, and you're not familiar with the C2 Wiki, then you're missing out on a whole era of like programming patterns that were super valuable and contributed a lot to like how Ruby on Rails kind of was formed in some ways. And so definitely take a look at that as well. And I haven't picked up the new Martin Fowler's new version of refactoring, but it's based off of JavaScript, I believe, too. So
Interesting.
for the examples that are used in the book.
Yeah, I think C2 Wiki is a huge trove of knowledge. It is also very much of a time, and the notion that like most of your programming would be in C++ is kind of embedded in some of the philosophies there, but also embedded in the culture. And I think that like the tools that we use influence not only the things that we build, but our culture and how we relate to each other. And there's like an intense brutality to C++ when you have certain kinds of errors and undefined behavior that creep up, and where they like hoist this desire to have a perfect mental model of your problem and the code and the compiler and the underlying machine all at once in your brain, versus something where the errors are less ruinous in things like Rails, where you might throw away the entire state of the application between each page load. So I think that's pretty interesting. So it's also a time before we were perhaps more kind to each other. So some of the comments and things that you'll see in there reflect that history. And not that I think that we should get rid of it, but you should take it with a healthy dose of skepticism.
That's good. So for anyone that's listening that hasn't looked at it, definitely be aware that there was a time and period. I think they were writing, a lot of that stuff was written in a way that was very, they're patterns that they're kind of maybe encouraging people to follow I don't know, I wouldn't interpret them as maybe being rules, but I feel like they're maybe written in a way that come across like they're
Mm.
laws or rules in some ways. I definitely, I didn't, if they, I think there are laws probably in there, and they use that, I think, in certain scenarios. But it'd be interesting actually for myself just actually go back and like look around and just to think about that.
As far as this relates to maintainability of software, one of the things in C2 Wiki, and they're all based on these like pithy little phrases that are the titles of the article. One of them is something called the 4-star programmer. So, in C, when you have pointer indirection, you use an asterisk to do that. And if you have a pointer to a pointer, you'd have 2 asterisks to dereference that pointer. And so if you have a 4-star programmer, it's someone who uses 4 layers of indirection to actually get to the point. And it's viewed as both somebody who it's really hard to keep track of that in your brain, but also maybe something that you shouldn't do because you're too clever. And while that thinking of 4-star comes from the C world, we could think of the same thing in Rails and JavaScript and Java and Go even.
So I want to transition a little bit. And what is your current take on the metaphor technical debt? Do you use it at all in your day-to-day work? And if so, how do you define it?
I do use it. And unfortunately, I'm one of those people that is making it mean less and less over time. So I think that a few of your guests have talked about how technical debt is a grab bag for everything we don't like about a current state of a code base. I think that more properly, the intentional decision to defer work is really the key of it, right? You pay now, you pay later. When you pay later, it costs more. I think that was Camille actually who said that. I think that's right. I think that there's always a maintenance burden to anything that you own or operate. So if you're in the kind of position where you could buy a home, you should allocate 1% of the home sale price to maintenance per year. And so if you aren't actively replacing the filters of your furnace, or even just like the roof has to be replaced every 10 years, is an aged roof maintenance, like technical debt of your house? I don't know if it is, but there is some like obligation that is going to come due regardless of your best design in the beginning, if you will, right? No complicated system continues to operate without ongoing human intervention.
I think about that example when like the house or a roof, and is there like another aspect of it? Like, some things are just going to last a certain amount of time and then you're going to have to replace it because it's just, that's the life cycle of it. I think it's interesting to like trying to think about very specific examples that correspond to software. It's like, well, is it likely that the JavaScript framework that you're using right now is going to be replaced at some point? Historically, that has been a trend in the web software world. Like at some point, you're going to have to swap it out. Maybe that won't be the case in 10 years from now if the frameworks are at a certain state that they're able to continue being worked on and iterated upon. I don't know. I don't know if you have any predictions there, but maybe there's another aspect to when you have a roof, if there are ways to take care of it, like, oh, it's collecting some moss, or there's some treatments and things that you're going to, like, I live in the Pacific Northwest. And so there's always this green stuff growing on top of the roof. And like, we need to get that stuff cleaned off to hopefully preserve that 10-year length of the roof in the first place. So there's almost like maintenance on the things that are even going to have to be replaced potentially as well.
Absolutely. So to carry over the analogy to software, dependencies experience bit rot. I spent a fair bit of time in Python the last half decade, and the surprising amount of code bases that were still on 2.7, even after Python 3 had been out for 10 years, shows that the appetite to adopt breaking changes in your dependencies is pretty low for most engineers. And I think that over time, we are seeing a greater investment in stability. But with that investment in stability, you get kind of frozen in time in the paradigms that were prevalent at the beginning of the code base framework or language. So we see things that like Java's type erasure will never be fixed. It can't be, because that would be fundamentally a breaking change, and that's not how they do things. So when something else comes along that has more robust type systems and type preservation, is like generationally better. We see this in science too, where like science progresses one generation at a time, or one retirement at a time, depending how pithy you're trying to be. Where people are kind of like stuck in their paradigm and their whole worldview is shaped by the way that they came up into things. Besides dependency, right, there's also like the environment as a whole is changing surrounding you. So when you think of like, why is Nagios maybe not relevant today? It's like, well, systems aren't long lived, right? This notion that you would configure, okay, these are my 5 systems, whatever, and these loads I have on these systems. It's like, okay, well, now I have 20,000 systems and their average lifespan is maybe a few hours instead of measuring uptime as like a bragging point of this service been up for 2 years. So these paradigm shifts, I think, lead to, if not bit rot outright, at least like something becoming outmoded or outdated. And you're right, there is active investment we can do to keep up with the underlying evolution of the ecosystem. Fundamentally, though, I think everything has a life cycle and we should embrace that life cycle. So what does it mean for something? When will this be end of life? And that for prediction should shape also the tools that you select. So to your point around JavaScript frameworks and the almost ephemerality of them would definitely shape my decision making and tool choice if I were to create a software project for a company that is not technology first, that's going to want to have something, you know what, I just want this to work, right? Like a point of sale system, many of which have been operating for 20 or 30 years without major modification. Like that is incredibly valuable, much more so than something that is more of a flash in the pan. When we think about value, we tend to think about short-term ROI, but if you're hopeful that you're going to continue to stick around, really having that long-term view sets you up for success later, if you can afford it. Again, if you're in that product market fit discovery stage, the time to iterate is by far and away the highest dominating factor.
Being able to pivot and knowing that your business model that you're hoping to, like that early startup phase, I think there's always an interest. You mentioned that you'd worked on probably a number of projects in that era, at one point, and you're in a much different environment now, I would imagine, where I think Netflix is some sort of product market fit at this point. I mean, and I still would be curious, obviously where the future there is. I'm sure there's still a lot to be figured out in that world. Is it safe to assume that Netflix has its own fair share of legacy code and accumulated a healthy amount of technical debt?
Oh, absolutely. We're pushing 20 years old now. And the initial code bases go back to being manually deployed into a data center with Oracle as a big database. Now, as far as I'm aware, we haven't had Oracle for a fair bit of time. And we did the migration to cloud like many people have, but we did it 10 years ago. So our cloud deployment is a legacy system, which is kind of funny to think about. And we are continually trying to fix, maintain, and even replace. And at a certain point, we'll achieve something like the ship of Theseus, which is this idea that, if you have a ship and over time you slowly replace each of the boards in the ship, is it still the same ship? That's where that term ship of Theseus comes from.
A little bit like our skin I don't know how often our skin replaces on ourselves. Are we the same person that we were? But exactly. I'm getting a little too weirdly graphic on that. So anyways, let's go back to ships.
Right. So we are continually in the process of trying to beat back entropy, frankly, which requires continual additional input and effort. We are experiencing one of these paradigm shifts from early cloud, which is the same era that we had like Capistrano, perhaps as a state of the art in the Ruby world for deployment, to in the very modern era, everything's declarative and you kind of state what you want the state of the world to be, and then you have a bunch of solvers that then converge upon that state. And so how do you migrate 4,000 different network deployed applications from a very procedural kind of deployment method to a declarative deployment method without having substantial downtime and without asking the 2,000 engineers, and by the way, there are fewer engineers than there are running systems, different applications, to take a bunch of time to focus on that. That's a non-trivial problem. And so like in particular in the infrastructure side of the house of Netflix, and all of our time is spent on migration, frankly, and trying to keep things working while making them slightly better.
I wanted to talk a little bit about an article that you published. I think it was maybe a little over a year ago, called The Myth of the Sufficiently Smart Engineer, where I'll also include a link to this in the show notes. But in the essay, you touched on teams often fall into the trap of believing that they, and I quote, are at a lesser risk of experiencing a negative event compared to other, say, teams. What do you mean by this? How does this manifest itself within teams?
Sure. So there's a bunch of different cognitive biases that different people have, and that's called like the optimism bias. Basically, we're hopelessly optimistic all the time, and we always think, oh, things are probably going to be okay. And that manifests in how we underinvest in recovery and escape hatches and manual interventions as operators in our human-computer interaction or our socio-technical system. And it also manifests in terms of how most people, I think, undervalue, say, test coverage or other kinds of preventative methods. And I think that we also use that optimism for ourselves to then be kind of cruel to people who do experience those failures. So you have the added benefit of having overconfidence yourself with the hindsight bias of understanding what, particular additional set of facts would collaborate to cause calamity, and hold that against somebody else and say, if I were in their shoes, I never would have fallen into that trap. But of course, if you fall into a trap yourself, it's like, if only I were a little bit better, and I'm never going to do that again. So we have all different kinds of ways of basically using additional information to be mean to ourselves and others. And that is really problematic for our industry. And it excludes people who are super kind and warm-hearted. And it also means that we don't make wise investment choices for the long term when we're building and designing and maintaining our systems.
Thinking about you mentioned like escape hatches that caught my attention there. And I'm, you talked about it, like writing automated tests and all these things that sometimes are like, well, those are catch like those weird edge cases or something, or like it's always interesting when you have like a rollout deployment plan or when you're going to migrate something. It's always interesting. Sometimes I'll have to remind my team, like, no. Where's the rollback process? Like, what if something goes wrong during this thing? What is our backup strategy to get back to where things were working as they were? Is this a one-way only thing, or we're just gonna if it breaks in the middle, we're just gonna have to brute force figure out our way through the rest of it? Let's take a step back moment. Like, is there a way to do that? And I feel like that always ends up being a far less time invested in that stage of shipping something and just being like, oh shit, there's a problem,
Absolutely. Bezos, who may or may not be a problematic figure depending who you talk to, has this notion of type 1 and type 2 decisions. And type 1 decisions are those that you cannot easily reverse, and type 2 decisions are ones that you can. And that the value of what investors would call optionality, or the ability to choose whether or not you want to participate in the future when you have more information, is incredibly undervalued by most people. And so you should actually be willing to spend a pretty high premium to turn a type 1 decision, an irreversible decision, into a type 2 decision, which is reversible. Now, whether or not reversibility in a living network addressable system is actually possible or not in the general case, I don't think it is in the general case, certainly not without more exotic architectures like using Datomic or things like that. But I think in the majority of practical cases, it absolutely is achievable and we should fully strive for it. But I think escape hatches go beyond reversibility of deploys. I watched this show called Star Trek for a little while when I was younger, and they always run into these issues with the ship and be like, okay, well, now we have to go into the Jeffries tubes. And it's like, what is that? And it turns out they made it up for the show. But it's a network of access tubes and little crawl spaces, effectively, where they can get to different parts of the innards of the ship to make a tweak. And so the question I have is, like, does your software system have Jeffries tubes? So this could be something as simple as an administrative panel where through a couple clicks you can make manual adjustments to a database with appropriate logging. It could be something more robust, such that you are custom tweaking rate limits or throttles or things like that through a system that can then propagate out to the rest of your currently deployed stuff. And thinking about the running system not just as a software product, but as to use some jargon here, a joint system or joint cognitive system that combines the people involved with operating and maintaining it, as well as the technology that you've produced itself. And doing that joint optimization between the two, I think, is something that we tend to really underinvest in, because product managers and even developers themselves both share this hubris that if we just get it right in the beginning, then why would we need to build all that stuff? But I've never, ever, ever seen that happen. And my wife's uncle is a operator at a power plant. And you think, okay, power plants, very high capital investment. They've been not hugely changed in design over the last 50 years. You'd think, they're probably low intervention systems. Well, no, everything requires ongoing human intervention. And you need to build that in, I think, from the beginning, frankly, to really get it right.
In your article, you also mentioned that due to this type of problem, great engineers aren't sometimes applying to top tier companies because they don't believe that they're, as I quote, sufficiently smart enough. Is this similar to feeling intimidated, or do you mean something else by that?
I think it's a specific type of intimidation that involves a kind of self-selection out, where you think that there's this like great halo or aura that surrounds the companies that are most famous and pay extremely well, that their engineers' poop doesn't smell, to use a very crass phrase. But I know this podcast is marked as explicit, so maybe I'll let that one through. And it's just not true. When I broke into, Netflix, as it were, I was expecting everything to be just the cream of the crop, if you will. And to be clear, my coworkers are the cream of the crop, but they're still people. And they still have dirty kludges and quick hacks and a whole bunch of cruft that you're like, why does this still exist? Come on, surely someone would be frustrated enough to fix it. And then you think, okay, well, they're a two-person team that built this incredible thing under a lot of time pressure. And now the business has shifted a little bit, so it's no longer prioritized. And there's a belief that this other system would eventually replace it, but that got defunded when the key person left the company. You've heard this story 1,000 times. And as a result, Netflix has a lot of amazing software and a lot of amazing engineers, but it has a lot of the stuff that you have to deal with in any large, long-lasting software company. And from what I've heard from people that work at the other quote-unquote top tier, sorry for the elitism intrinsic in that statement, tech companies, that it's the same mess. Now, some companies value having less of a mess than others, but at the extreme penalty of being able to get quick stuff out. So like the space shuttle, if you look at they are at like the software maturity level 5 or whatever it is, whatever the model was at the time. And that probably makes sense, right? Tens of billions of dollars getting invested in a single moment. You don't want that to go wrong. You're willing to pay very high costs, very high latency in order to have a higher predicted success rate. But that's not how I want to work, right? Like I said earlier, I don't really care about the cleanliness of the code and the page. I just want to get this stuff done and make sure that like the concepts kind of make sense over time. So I think fitting yourself to the culture of the company that you try to approach is also really important when you think about that. And to get back to your initial question, I think that people on the outside view many of these famous tech companies as always having perfectly high standards of quality. And we do want you to do your life's best work, but that does not mean making every single thing done in a perfect way. And frequently that would be a very poor use of judgment if that were how you approach your work for the kind of work that we do, where we have a huge investment in reversibility. So I don't know the exact numbers of the amount of deploys that we push out that we roll back, but it's certainly not zero. And it's certainly not zero on any given day, right?
Even my own personal experiences in this world over the last 15, 20 years, like I think I would, if I hadn't started my own business and gone down my path, like I would have been intimidated to probably apply at somewhere like Netflix. Or I remember being called in the early era of Ruby on Rails. Google contacted me and they wanted me to come down and do some interviews, and I was like, I don't know that I'm qualified for that. And just like I'm not. You're mistaken. I think you're talking to the wrong person. I blog a bunch. I know how to use this new thing, but like I don't know what the hell I'm doing. In some way, just as being open. I think in some ways I might have avoided some opportunities because I was like, they'll find me out.
Yeah, totally.
And
totally.
I'm like right now I see like I know what I'm doing, but
nobody knows what they're doing. So I'm going to call you out on that. I think that's one of those things that we perpetuate is that like, I've arrived. There's this belief that like once you always want to climb that next peak, if you will, on the mountain range. I'm just a guy with a bachelor's in psychology from a third-tier university. I'm not Netflix material or whatever. I definitely struggled with those feelings. And through a series of fortunate accidents, had a startup that I was working at that got acquired and found the love of my life. We got married. And so I was riding high on a series of successes and overinflated ego. A person actually that I had done some contracting with in the Rails community 10 years prior had reached out to me and was like, okay, you should really come check it out. You don't have to worry about applying. It'll be a casual meet and greet. And I did that meet and greet. And I was so enamored with the people I had the potential of working with. And I had a good job. So I was like, okay, it's very low risk. So what I'm trying to say here is I had every single privilege that you could imagine, all of the successes, and only then did I feel comfortable actually making an application. Which, if the bar was that high for someone who has had every, leg up, if you will, in the world, I can only imagine how much self-selection there is of people who are truly fantastic. And I don't even have to imagine. I have good friends who to this day I know are like amazing programmers. They're like, oh no, I'm not ready yet. I'm like, what are you waiting for? There are people at Netflix who I'm just like, okay, they were probably aliens or robot aliens. But the overwhelming majority are just like very experienced, very capable, but still human engineers. And I think that is really sad. And I want to figure out how we can break down this exceptionalism that has formed around certain types of companies. Because at the end of the day, you're just a sack of water sitting in front of a keyboard. And if you put the time and effort in and really work hard at taking ever escalating problems of complexity and time, I think both of those axes are important, then I think there's no real barrier for most people to be able to get into the hardest, most prestigious companies.
We'll be back with our interview with Aaron in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to say thank you for making time to listen to the Maintainable podcast. If you're finding these conversations valuable, please consider sharing a link amongst your peers on social media. Maybe consider writing a review on Apple Podcasts or Stitcher for extra credit. Also, do you know someone in our industry that I should be interviewing on Maintainable? Shoot me an email to Robby with a Y at maintainable.fm. And now, back to our interview with Aaron Blohowiak. Another thing you touched on in that article was related to how leaders within organizations, what you're advocating for is that should talk more about their mistakes or their errors that they make. Can you share some good examples about how you've seen leaders do that well, whether that be yourself or other people within your team?
Sure. And I would like to split a hair here around mistake and error. I think that mistakes are kind of normative and intrinsically based in hindsight, whereas an error is like an expected part of how any system operates. Like nothing is without fault, if you will. So some people view actually the exact opposite, where they think error is intrinsically judgmental, whereas mistake is more humanizing. So, however you want to approach it. But to me, we all have these sorts of like probabilistic predictive models of the current and future state of the universe. And intrinsic in that probabilistic model is a distribution of outcomes. And so even if the result that you see isn't the one that you desired, it doesn't mean that you made a bad decision, right? That's called resulting, where you judge the quality of decision making by the quality of outcome. And you want to really avoid that. So there are two different types of successful acknowledgement of error. One is, well, the dice didn't land the way we thought it did, and still think we made a good decision. And that is the kind of admission that most organizations will make regardless of the quality of decision making. The other type of admission that we tend to see is, well, the outcome wasn't what we thought. So if only we had tried harder to do a bit more research or a bit more diligence or moved a bit faster or worked more hours, then we would have had the better outcome. Lesson learned, let's do better next time. That also, I think, is a really bad way of framing the experience because it assumes the ability to have perfect information. So I think that like the best ways that we have confronted errors are, this is what we thought at the time. And I think everyone makes decisions that make sense to themselves at the time. Here is what we learned. And as a result of this learning, here's what we'll do next time, which is similar to the second kind that I mentioned, but without all of that post hoc justification, blame game. And a lot of that blame game is even self-flagellation frequently, but it's much more just acknowledging that the world is full of uncertainty. So one thing that was drilled into my head when I first joined Netflix was around what was ultimately spun out as Roku. So a lot of people don't know about this, but Roku was started as an internal project to Netflix to create a set-top box, basically, that could plug into your TV. there was a lot of internal debate about it because Netflix's success in no small part has to do with the strength of relationship that we have with many of the different platforms, right? So if you have bought a TV recently and you look at your remote, it may likely have a Netflix button on it, right? That's pretty valuable. If we had gotten into competition with those device manufacturers, that would potentially pose like a non-material risk to their willingness to be friendly with us. So what had happened internally was at the 11th hour, apparently, like before this thing was to be launched, there was a decision that, oh no, this really is a risk. We need to turn on a dime and actually spin this out as an independent entity that won't be, exclusively focused on Netflix and where Netflix won't enter competition with our partners. And that came all the way up to the top. And our CEO admitted, he was wrong in the direction that he had picked, given the information that he now had, but that the information he had at the time, they hadn't really considered all of the potential implications. And so that is something that you're taught in like your first or second day of joining, was that, this is the extremely valuable lesson here, is that we are the kind of company that says, oh, this is wrong, let's do something else. And I see that over and over and over again.
You had that when you were talking about that kind of framework, it's like, this is what we thought, here is what we learned, this is how we can do better this next time, or how you're going to approach things next. Do you often use any language around things like let's try this next time, or let's do this, let's experiment with this, like using any key language to know that it's not a permanent thing that you're going to be doing necessarily, like this is the de facto best possible way? It's just like we're going to, like, if you don't know if you go through any like conversations that might pop up like in, say, like a retrospective or something like that in your team, like how do you talk about, like, how do you iterate on something and try things out, maybe like a...
Yeah, absolutely. And I think that the most frequent source of big errors that I see is a lack of incrementality. And if you place one very big bet at the roulette table on red without having any like extra information that it's likely to land on red, then that's very painful when it goes wrong, right? But if there's a way of structuring your investment such that the amount of investment that you make is commensurate with the amount of information that you have that increases the probability of success, then any small setback along the way is either something you can route around, or it's less, your total investment that you have to throw out is going to be less over time. And so like the main theme is, oh, we wish we had made it more incremental, which is very similar to the type 1 versus type 2 or reversibility kind of thing that we're talking about earlier. Being able to pay more overhead to have more confidence building over time. Viewing things as experimentation, and as this is both a knowledge discovery project as well as a building project. And those two aspects need to be treated maybe not co-equally, but at least with the same level of esteem, is really key. Because we do have that like overconfidence in our ability to predict the future, frankly.
Circling back to our earlier topic related to technical debt and such, Netflix has, I mean, I'm sure you said there's a lot of systems in place. What types of processes have you seen work well for prioritizing dealing with some of that maintenance work? Do you, like, when something, like someone comes across something in the code, like what is a typical, like maybe your own personal experience, if you come across something in some code you're working on and you're like, this probably needs to be refactored, we need to iterate on this a bit or come back and clean this up, what is your kind of strategy for dealing with that, or knowing that you're not going to take care of it right now, but it needs to be taken care of?
It's so hard. Like, I've never seen it be great or easy at any place that I've ever had the fortune of working. And I've worked at a lot of incredible engineering institutions, many of which, like I said, are small startups, but some of which are quite large. I think that one thing that Netflix in particular does very well is valuing the expert judgment of the people that it employs at every level. So if someone on the team says, this is important and needs to be fixed, usually their manager trusts them to do so. Now, most engineers who have, 10 years of experience or more are rarely so confident that this is particularly the thing that needs to be fixed. So a common pattern that I've seen is this, living with it for a little while and seeing if it continues to rear its head, seeing if it continues to be a thorn in the side. And then you start to have this prioritized list of, well, if I had time, I would do a thing. And then eventually you dedicate a certain portion of your budget to accomplishing that rework that refactoring, that sort of task. I do think, though, that an alternate approach that I've seen work very well, that I'm personally a huge fan of, is entirely other side of things, which is, build things so that it's easy to throw them away. And the advent of microservice architecture makes this very easy. And part of how it makes it very easy is by having a very clearly defined boundary and interface. So if your service has just a few endpoints with clearly defined inputs and outputs, then doing a rewrite is not a big monstrous thing, right? If the rewrite lasts less than a quarter or 3 months, it doesn't suffer all of the problems that, say, Joel Spolsky has expounded upon ad nauseum. And the deploy also can be very progressive if it has the exact same inputs and outputs. And you can even do cool things, which I've seen, where people run shadow traffic or they mirror the traffic from the live system to the system that will be its replacement, and then confirm that all of the outputs match exactly. And when you do that, it lets you really focus on fixing the insides. Whereas if you take the approach that, hey, we'll address this debt when there's a new feature, well, now you have introduced two types of risk. You've introduced refactoring risk and the expansion risk from the additional functionality. So that's a pattern that I would like to see more people do. But if you approach microservice where this sort of thing is easy without a substantial investment in your infrastructure of making microservice management easy, you're going to have infrastructure debt, which I would claim is like way more painful than refactoring debt inside of a code base. So, and that could just be because I'm closer to it. So pros and cons, pros and cons. You talk to anybody to ask one of these, binary decisions, and it comes down to, well, it depends.
I want to touch on a few last questions with you, and thinking a little on the fly here based off of some of our earlier conversations. But again, I'll definitely include a link to your article about, the myth of the sufficiently smart engineer if you want to Google that, to those listening. It's a very good read. And I'm really curious, like for those listening, so maybe if you get some advice from you, Aaron, let's imagine there's some junior developers listening, and maybe one day they hope they can work at a place like Netflix. But let's say they're working in an environment where there's automated testing, and they're kind of they're still new to it. They're wrapping their head around, they're seeing examples of how it's written before in their code base, and they're like, okay, I can kind of follow this model. I see when I'm working on a feature or I'm fixing a bug, how this kind of, the testing kind of helps account for that small type of scenario. But they haven't really seen like the long-term payoff of having like a healthy and robust test suite, because they've never really had to deal with the pain of when there was an absence of good test coverage. What kind of advice could you offer them to kind of like know that that's a good investment, and that, or for those that haven't even started making that professional development time investment into doing that, or maybe they're even more senior people, they don't value it, and so they're but they hear about it. What kind of advice could you offer them and how they navigate that? And
Absolutely. So if you are a junior developer and you are working in a dev environment where there's not a strong culture of testing, get a new job. That's kind of harsh to say, and I know that getting a new job, especially in these times, is not easy. So don't quit your job before you have another one lined up, but definitely put your ear to the ground and start looking out for other opportunities. And there are two reasons for that. One, the experience that you're building now is not the experience that's sought after by the best places to work, frankly. And the other reason for that is you're developing a series of bad habits and a series of viewpoints that are going to be really informed by your early experiences. So when you don't have a lot of tests in the code base, what you end up doing is relying on the original author, most frankly, or the person who has the most experience with the code base, to act like the hero and wear the cape and be the person who comes in and solves the hardest problems, or who can then browbeat you for not understanding some arcane nook and cranny of the system. The immediate advantages of having that test coverage that you probably don't appreciate if you are working in such an environment is that when you make changes, you'll know if you broke something else that should be unrelated, but the isolation of the particular component you're working on isn't perfect, and it never is. So that sort of like prevention of unintended consequences is something that you don't really appreciate unless it's gone and bites you in the butt in production. As far as the long-term aspects of having high standards and high investments in the long term, including testing to a certain extent, I don't know if there's value beyond, say, 80% coverage, but that's a debate for another day. What I would say is, if you can't observe it, yourself directly. There is a certain value to finding people that you want to be like. And I do this in my role today, where there are people that I look up to, heroes of mine, and you've had many of them on this podcast. Jessica Kerr, you had Camille Fournier on here. And I think like, well, those people are really smart, and I value so many of the things that they say, and I find a deep truth in it. So when there's something that they say that I don't understand, it could be that I haven't spent enough time with it, that I don't have yet enough experience with it. I try not to dismiss it or think that I know better. Now, on the flip side, I also try not to just accept what they say out of hand. And so one of the things that I like to do is to look at the reasoning behind the thing that's being stated, to avoid the sort of like cult of personality or cargo culting or anything like that. And since the reasoning here is the long term, and we know that as a junior developer, you haven't experienced the long term, in the absence of firsthand observation, you should take other people's experience as a, source of truth, if you will. The final thing I would say is like, if you are working and you have not yet worked in a very old code base without tests, that is also an experience worth having. Because while you may not be sitting in your own filth for a long period of time, it can be an even more jarring experience to early in my career, I got exposed to some 7-year-old PHP code bases back in a time before there was Laravel or any of the other PHP frameworks that I now know help create some organization. And that put in stark relief, in my mind, the value of what is essentially overhead, right? Investing in not only tests, but deployment, even documentation, single responsibility principle, all of these things that take time away from adding, quote, direct business value, end quote, in terms of functionality that the end user can perceive, but really make the engineering more capable and faster over time. And then the final way that I would try to explain this to a junior developer would be that your job is not to produce features today. Your job is to produce features every day for as long as this company is a going concern. And if you are taking shortcuts today, you are putting a huge burden on future you, if you will. And so when I was earlier in my career, I'd say, oh man, next week Aaron is going to hate today, Aaron. Because, and frankly, we've all been junior developers. The desire to sell out your future self for the sake of today is kind of one of the hallmarks of youth. So it can be good to have that perspective on the team, and don't be too ashamed or bashful about your youthful naivete. It's refreshing to the grizzled and sometimes overly skeptical senior engineers on the team. So just, embrace the part of the cycle that you're in.
I think that's some like very good sage advice there. Thank you so much for opening up about that and giving some advice to folks on navigating that world. As we wrap up, a couple last quick questions. What non-programming book do you find yourself most often recommending to people in the industry?
So when you say non-programming, I think that we really are building these socio-technical systems that are joint people and software. And so if I were to say, like, what are things that are on the people side, I end up doing a lot of mentoring of people who are entering people leadership or technical leadership roles. So I end up recommending Radical Candor from, I believe, Kim Scott is the name of the author. And I listened to it on Audible, and she is not used to reading stuff. So the first 30 minutes of audio is not so great, but the content is amazing and it's worth sticking through. She gets much better as a narrator, or just read it on the Kindle. It's pretty easy. For people who are not really interested in other people and relating to them well yet, and you probably should be, the book that I think was most expansive while being accessible that I recommend to a lot of folks is Thinking in Systems by Donella Meadows. And she was part of MIT through this phase of systems thinking in the late 20th century. And what's fascinating is she presents these very complicated ideas of how systems of parts interact using very accessible examples, but then also extrapolates to how their use could be made in much more sophisticated ongoing things. If you're not yet into the world of systems thinking, that is a great entry point.
Excellent. I'll definitely include links to both those. I read probably half of Radical Candor and should probably pick it up again at some point. I remember there was on the audio side. I think they had started a podcast and they didn't. I think it kind of fell off pretty quickly. But I was like, "Ooh, cool! There's going to be a podcast about this topic." I'm like, "This is exciting," and then it never really. I think it kind of died off there. But well, where can listeners best follow your thoughts about software development online?
On the Twitter. I'm twitter.com/Aaron Blohowiak, and for that you'll probably need the link.
Well, it's been such a delight having you on Maintainable, Aaron. Thank you so much for having such a thoughtful discussion with me.
Oh, this has been such a real pleasure. And if anyone wants to continue this conversation, you or anyone who's listening, I am super into talking with people about their experiences and how software and the culture of software developers interacts with software over the long term.
Awesome.
So please feel free to reach out to me either on Twitter, via email. It's my full name @gmail.com, or DM me. Or I'm not on Insta or TikTok, so don't try that stuff. But thank you so much.